Besok tak tahu macam mana. Tak. Yalah. Ya. Alright. Hello, Assalamualaikum warahmatullahi wabarakatuh. Okay, good. Her name is there. All right. Amira. Okay. All right. And Aji. Okay. We continue on. Okay. Basically, we have done the, we call it the capital budget. Okay, capital budgeting based on the NPV. You discount all your cash flow, right, to year zero, minus with the initial investment, then you'll get the NPV. For example, for these two projects, for project L and project S, we will choose project S because it gives us more return, 19.98 as compared to 18.79. So this is how you want to calculate using your, we call it your financial calculator. So it's very easy, okay, very easy. So you'll get the formula, the answer, 18.78 for L and also 19.98 for S. Okay, so rationale for the NPV method, NPV is equal to present value inflows minus with cost. This is net gain in wealth, so accept project if NPV is greater than zero. Okay, if its NPV is greater than zero, you can accept. Below than zero, then you reject. If you have to choose between mutually exclusive project on the basis of higher positive NPV because it adds most value. So in the case of this, we choose NPVS, okay, because we have to choose either one, right? Because our capital is 100 only. So if we have this 100, so which one can, that 100 can give us more return, okay, in terms of these two projects. All right, so if franchise S and L are mutually exclusive, except S because NPVS is greater than NPVL, and if S and L are independent, accept both. Okay, if it's independent, then you can accept both. NPV is dependent on the cost of capital. Okay, the cost of capital just now is 10%. So if we use the WACC, then we can use that WACC to calculate NPV. All right, okay. So, and then there's an important, we call it topics here is the internal rate of return, the IRR. So here, for example, we have the cash flow, the 0, which is the cost. Then we have CF1, CF2, and CF3, which is our inflows. But we do not know what would be our IRR, what would be the cost of capital here. So the IRR is the internal rate of return. So what would be the rate that we need to discount, okay, if we assume that NPV is equal to 0. So our NPV we assume to be 0. So the formula is like this, CF, okay, and then divided by the discount rate equal to NPV, right? So NPV is enter R solve for NPV, okay? So IRR is actually enter NPV is equal to 0, solve for IRR. So you want to calculate this, but you put your NPV is equal to 0. So IRR is an estimate of the project rate of return. So it is comparable to the yield to maturity on a bond. Okay, if you calculate the yield to maturity on a bond, the same formula you have to use. Okay, right. So what franchise IRR? So if we have this initial outlay of 100, okay, our cash flow of year 1 is equal to 10, cash flow year 2 60, cash flow year 3 is 80. So we assume that our NPV is equal to 0. So enter CFLO, then press IRR. So IRR is equal to 18.13. So IRRS is equal to 23.56. This is we use the calculator. Okay, so which is the internal rate of return. Okay, this is 18.13, this is 23.56. So, and then find IRR if CF are constant. Now, our CF is constant, 40, 40, 40. So here is very simple, it's just like annuity, right? Okay, so input is 3, N is equal to 3, R is 9 point, PV is 100, negative 100, payment is 40, future value is, so, all right, your output will be 9.7. Okay, your IRR is 9.7. See, this is a bit simpler because the inflows are constant. So if IRR is greater than WACC, then the project rate or return is greater than its cost. Okay, some return is left over to boost stockholder return. For example, WACC is equal to 10, IRR is 15. So this project adds extra return to the shareholders, right? So if you look at your WACC, okay, that you have calculated just now is 10, then your IRR is 15, then you accept the project. Okay, you accept the project. If S and L are independent, accept both IRR. So IRR is greater than R and IRR L is greater than also R. So you both accept both. If S and L are mutually exclusive, accept S because IRR S is greater than IRR L. Okay, IRR is not dependent on the cost of capital use. Okay. Right, so this is how you construct the NPV profiles. Okay, you put your cash flow, right, 0, and find NPVL and NPVS at different discount rate. So this is discount rate which is different, right? So you need to discount every year. Okay, you need to discount every year because the R is different. So NPV 0 is, cash flow 0 is 50, CF1 33, and then 19, then 7, then negative 4 in this year 4. Okay, for NPVS is cash flow 0 is 40, and then 29 for year 1, 20 for year 2, 12 for year 3, and then 5 for year 4. Right? So here, this is the NPV profile. So the crossover point is 8.6. Right? This is L, this is S, IRR is equal to 23.6, then this is IRRL is equal to 18.1, right? Okay, 23, and then this is 18. So discount rate is this, okay? All right. So NPV and IRR, no conflict for independent projects. Okay, for example here, look at the IRR, and then this is IRR is greater than R, and NPV is greater than 0, you accept. So this is R is actually greater than IRR, right? And then NPV is lesser than 0. So you see the NPV is lesser than 0. This is the NPV is lesser than 0. It's negative. So you reject. So here you reject. So here you accept. Okay, mutually exclusive project. Okay, mutually exclusive project. So you look at R is equal to 8.7. So this is R equal to 8.7. NPVL. Okay, NPVL is greater than NPVS. So we accept L, okay, IRRS greater than RRRL. So conflict, there is conflict. So because here we should accept S, here we should accept L, so conflict. But if it's greater than 8.7, okay, NPV is greater for S, okay, is greater than NPVL, and IRRS is greater than IRRL. So no conflict here. So here no conflict because this is greater than this. Okay, mutually exclusive project. To find the crossover rate, okay, to find the crossover rate, find cash flow differences between the projects. See the data at the beginning of the case. Enter the difference in CFLO register, then press IRR. Crossover rate is equal to 8.68%. Rounded to 8.7, can subtract S from L or vice versa, and consistently but easier to have first CF negative if profile don't cross, one project dominates the other. Okay, right. Two reasons NPV profile cross: size, scale, or differences. Smaller project frees up fund at T equal to 0 for investment. The higher the opportunity cost, the more valuable this fund. So high R favors small project. Then because of timing differences, project with faster payback provide more CF in early years for reinvestment. If R is high, especially the cash flow, especially good, NPVS is greater than NPVL. Okay. All right. So any question for the calculation of IRR? Okay. All right. I will continue on the this one, modified internal rate of return, MIRR. Okay, MIRR is discount rate that causes the present value of project terminal value, TV, to equal to the present value of cost. TV is found by compounding inflows at WACC. Thus, MIRR assume cash inflows are reinvested at WACC. Okay, so MIRR assume cash inflows are reinvested at WACC. Right, for example, this, okay, we have initial outlay of 100, then our, what you call it, cash flow year 1, 10, 60, and also 80. So here, we will actually first find the present value and the terminal value, okay, using R equal to 10. So instead of discounting, we go to future value, right? So the future value is for year 1 is 12.1, year 2, 66, and year 3 is 80. So this is your terminal value inflows, 158.1. Okay, 158.1. Okay, then only you discount it at 16.5, which is your we call it the MIR. Okay, so M154 at 58, okay, divided by 1 plus MIRR, okay, power of 3. So then you can calculate to get the MIRR, which is 16.5. Okay, so this one. Okay, so this is MIRR. Okay, to find that terminal value with 12B, okay, step 1, find present value of inflows. Okay, first enter, this one is using we call it calculator, okay. CF0, 0, CF1, 10, 60, and then 80. Second, enter I equal 10. Third, find present value of inflows, press NPV equal to 118.78. Step 2, find the terminal value of inflows. So enter PV equal to negative 118.78, N equal to 3, okay, I is equal to 10, payment equal to 0, then press future value, you get 158.1 future value of inflows. Step 3, find the present value of outflows, okay, and then here there is only one outflow, which is negative 100. So the present value of outflow is negative 100. For other problems, there might be several negative cash flows for several years, and you must find the present value for all negative cash flows. So step 4, find IRR of terminal value of inflows and present value of outflows. Enter future value 158.1, present value is negative 100, payment equal to 0, N equal to 3, so you get 16.5 for your MIRR. So that is how you calculate modified internal rate of return. Okay, why use MIRR versus IRR? MIRR correct assumes reinvestment at opportunity cost equal to WACC. Okay, and then MIRR also avoid the problem of multiple IRR, and manager like the rate of return comparison, and MIRR is better for this than IRR. Okay, all right. And then we look at the profitability index. The profitability index, PI, is the present value of future cash flows, okay, divided by the initial cost. It measures the bang of the buck, okay? So it's how you do it, okay? You take this, all your present value, all of it, okay? You get 118, okay? 118.79, okay? This is all your present value. Then the present value of future cash flow, you divide it by the initial cost, so you get 1.18. So the profitability index is 1.19 for S, L is 1.18. So if you look at the profitability index, PI is better, or S is better for compared to PIL. Okay, all right. So what is the payback period? The number of years required to recover a project cost, and how long does it take to get the business money back? So now we want to calculate the payback period. So here we have, we call it, we want to calculate when we will get this 100 back, okay? Okay, all right. In the first year, you get 10. The second year, you get 60, all right? Then you already have 70. You still have 30. So when do you want to recover 30? So it's between 2 years and the third year, okay? The second and the third year. So that's why if you calculate, okay, so for example, 2, okay, this is 2 years, and then plus 30 over 80. 30 over 80, which is about 2.3. Okay, 2.37. This is your payback period for franchise L. For franchise S, 1.6 years. So it's better compared to payback L. Payback S is faster, 1.6 years. Okay, 1.6 years. Because in the first year, you have already received 70. You only need another 30. So how you do that? 1 plus 30 over, this is 50, right? So this is actually 1.6 years. Okay. So strength and weakness of payback, okay, provide indication of project risk and liquidity, easy to calculate and understand. Weaknesses, ignores the time value of money, ignores the cash flows occurring after the payback period, and also no specification of acceptable payback, okay. All right, it's easy to do, but there is some, we call it, now this is actually using discounted payback, okay. All right, so before I'm going to go into further detail to this, I'd like to see whether do you understand about the capital budgeting, okay, the capital budgeting for NPV, all right. So NPV, IR, okay, NIRR, okay, profitability index, and payback period. Okay, this is the 1, 2, 3, 4, and 5. We call it important formula in capital budgeting. Okay, do you understand about this? NPV, IR, MIRR, profitability index, and also payback period. Any comments from the students? Rohi Jeng, okay. Is it you, Ali, Aji? Okay, good. So if you understand all of this, I don't want to go into further detail. Okay, I would like you to concentrate on these 5. 1, 2, 3, 4, 5. Okay, concentrate on this 1, 2, 3, 4, 5. All right. So you understand NPV, you understand IRR, you understand MIRR, you understand profitability index, and then you understand payback period. And then you need to know how to calculate it using your, we call it your financial calculator. Okay. Okay, if you understand about it, right, I want you to do one exercise, right? Okay, I want you to do this. Okay, this is your cash flow. But at this time, I'm going to change this, right? This to be 50. This is 30 and 10. Okay, can you calculate the NPV for this? Okay, can you calculate the net present value for this question? Okay, insert, new slide, okay. Okay, can you calculate, okay, NPV if the rate of return we are using the rate of return as 10%, okay? Okay, R equal to 10%. Okay, I'll give you about 5 minutes for you to do this to get me the answer. Okay, 5 minutes. All right. Okay, what's the answer? Answer please, Aji, Mira, and also Hanim. Got answer already? Market is not very good today. It's very red color, red sea. That is actually a systematic risk, market risk. As I foresee that market is going to 1420. Okay. Okay, can you get the answer? What's the NPV for this project? Can you type the answer here? Answer, anyone can give the answer. Okay. Initial investment is negative 100. Year 1 cash flow 50, year 2 30, and then year 3 is 10. What is the NPV for this project? $13.76. 13.76. Nope. It's negative 22.24. Okay, negative 22.24. Negative 22.24. So we reject the project. Okay, I'm giving you another one. Another one. This one should be 60, then this is 50, then this is 20. Okay, so what would be the okay, if I have another one, new slide. Okay. Okay, this is the cash flow. Okay, what will be the NPV? I don't think we need 5 minutes. Okay, 2.5 minutes. Okay, the new exercise, different cash flow, the same initial investment. Okay, what's the answer? Okay, please give me the answer. Haji, Amira, Hanem. What's the NPV for this one? Negative 1.6. Okay. Haji? Negative 1.6. How do you get 1.6? Negative 1.6. It's not correct. Okay, one negative 1.6. Okay. Must be positive. Okay, must be positive. Because this is 60, 50 is already more than 100. If you discount this to 1 year, discount this to 2 years, discount this to by 3 years, it must be, we call it more than 100, I think. Because this is already 6, 110, and 130. Okay, I'm not really sure. Okay, I'll just wait for Aji first. Where's Aji? Okay. Okay. All right. So, all right. So basically, okay, I will show you the answer. Okay, this is the answer. Okay. So because we have 60 here, we discount it by 10%, you get 55 for 1 year. Then we discount this 50, we get 41. Discount this by 3 years, you get 15. So you add all this together, 55, 41, and 15, you get 10.89. Okay, 10.89 because 55 by 41 is 96. So 606, 111. So this one is summation of this plus this plus this. Okay, 111. Then you minus, okay, this one equal minus with 100. Okay, sorry. $11. So it's actually 11. So 10.89. Okay, 10.89. Mira Ame, if we want to use formula, do we look at PV annuity table for discounting? Yes, you look at PV table. Okay, example, I'm going to open the PV table, okay? PV table. Okay, at 10%, 0.90909. Okay, and then for 2 years 0.82645, 3 years say 0.75132. You get to use this. Okay, I'm going to copy this image. Okay, and put it here. No, cannot. Okay, cannot. I'm going to give you this table. Okay, give this table, send it to financial management. Okay, all right. It's very simple. If you are using table, okay. First is you have to discount. For example, okay, this one. All right. 60 you multiply with table 0.90909. 0.90909. Okay, and then you plus with 50 multiply with 0.82645, 0.82645 plus with 20 0.75132, 0.75132. Okay, then you minus with 100. Okay, right. So you solve this one by one. Okay, for example, okay, 60 times 0.90909. Okay, you get 54.5454. Okay, plus with 50 times 0.82645 equal to 41.3225 plus with 20 times 0.75132, you get 15.0264. Okay, then you minus 100. Okay, so this is your NPV. So your NPV should be $110.8943 minus 100. So equal to 10.8943. So this is positive. So NPV is greater than 0. So you accept the project. Okay. Okay, you accept the project. Okay. So that's how you do it, okay? This is using table. If you are using calculator, financial calculator is much more easier, right? You can get the result very fast. This is using what I call it a financial table. So I think what I suggest to you is that you try to calculate, okay, try to practice, okay, practice more clear, more frequently, so that you can get the, what I call it, the calculation correct, okay? So you can actually try to do it at home, okay? I think I will actually end the session at the moment because I want to listen to the new cabinet announcement, right? The new cabinet announcement. So basically, I think we'll end the session now. Okay, you can actually look at the what I call it new cabinet that will be formed today at 5 o'clock. So with that, I would like to thank you. Okay, any question, please just WhatsApp me. Okay, WhatsApp me, or you can actually ask any questions that you want to ask. Okay, with that, thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.